The next subject matter, next program item is return flows and the irrigation efficiencies. Eric talked about the research that's been going on. He talked about some frustration with the time that it's taken us to examine some of the alternatives that we're looking at to address drought. Looking at one of those alternatives, irrigation efficiency right now and the consequences, is a panel that will address our general moves to modernize irrigation, improve water quality, improve irrigation efficiency across the arid west, certainly on the western slope. Unlined ditches being lined or piped, flood irrigation being converted to big guns, side roll sprinklers, micro sprinklers, even drip tape irrigation. The Colorado River District Board for the last 2 years has been discussing with some concerns this trend, and it's become clear that some of these new ways have some unintended consequences, both to water users and the environment. Leading this session and exploring this topic is Dave Kanzer, who works for the Colorado River District. You know him well. Largely focused Dave's work on irrigation modernization. And DK will set up this discussion and moderate this panel. I'll leave the stage, but I want to introduce his other two panelists. Don Schwint will follow Dave after he sort of sets up the conversation. Don, appreciate coming up from Southwest Colorado. He farms in the Cortez area, knows firsthand how changing irrigation practices have broader effects than initially thought. Don serves on the Southwestern Water Conservation Board, the sister district to the Colorado River District Board. He also serves on the Dolores Water Conservancy District Board. Then bringing a perspective from the Gunnison Basin is a longtime friend and director of the Colorado River District, Bill Trampy. Changing irrigation practices in different environments from the headwaters. Bill will explore that issue and perhaps suggest that one size doesn't always fit all. With that, I'll turn it over to Dave to set this up and take this over. Thanks, Dave.
Thank you.
Yep.
Well, good morning. What a great room, what a great day. I'm in awe of you all and for coming and joining us in one of my favorite events of the year. I've been lucky enough to be part of this on and off since its inception. And also want to talk about one of my other favorite topics, which is agricultural efficiency and modernization. And I think Jim Pokrant kind of had a nice, intriguing title, Return Flows. Irrigation efficiency goes up, they go down. I mean, that's sort of the bottom line that we all need to keep in mind. However, there's a lot more to the story, and I'm going to try to set that up for my distinguished panelists who know a lot more about this than I do. But before we get into it, some common terms, and I kind of stole this from Dr. Perry Cabot, who was in this room several years ago and talked about this topic. So, and he probably wasn't the first one to say, efficiency is just doing more with less. And I think we can all agree with that. And that's really our charge. As we heard from Eric in the previous panel, we have to do more with less. And irrigation efficiency more specifically, really if you want to get down to it, is the percentage of diverted water that is beneficially used or consumed. And you can see the equation there to come up with a percentage of efficiency. But efficiency is a whole lot more than that, of course. There's a lot of different types of agricultural efficiency, and you can really break it down into the efficiency from getting it from the river and conveying it to the point of use. That's part A. And then part B, of course, is how you apply that water and how much water you put on the field and how much gets to the root zone to help with the agricultural production. So the system efficiency And really that's been my charge, to look at increasing system efficiency across, mostly in the lower Gunnison, but really across the upper Colorado River Basin and throughout the basin is critical. And that's the combination of those two components. And of course, you look around your neighborhoods throughout the West Slope, you can see examples of this all over the place. The right-hand example, or the right-hand picture, is probably not the most efficient, you'd agree, trying to get the water from that point, falling down the hill, eroding the hillside, down to that reservoir on the far side. However, if you add some technology, you can make things a whole lot better. A few more pictures here. Another part of efficiency is trying to minimize spills, trying to capture that water and put it in reservoirs, and that's a big part of the equation. When you put together some efficiency improvements, sometimes you have the advantage of a reservoir to store those savings, and sometimes you don't. And that's a big piece you'll hear about, I think, more from our panelists. In addition, on field, on farm, you can see a lot of examples as people convert from the previous days of flood irrigation, which are still popular and very effective in the upper mountain meadow country, down to the valleys where some of the cash crops are grown and some more technology is used. And again, you're going to hear about those distinct differences between the upper basin, the upper Gunnison Basin, for example, and the lower Gunnison Basin, the Uncompahgre Valley. Same thing in the Grand Valley here, much different than the upper reaches of the Colorado River. So we've already heard about the law of unintended consequences. I'm sure you all deal with it on a regular basis. If you break it down, you're really talking about an unexpected drawback. And I stole this pretty much out of Wiki. I should have given Wikipedia reference here. But since Wiki is kind of a public domain, I'm going to steal this. I edited it to fit, but it's a detriment. It's something that happens in addition to the desired effect. So when you're irrigating, you're improving your quality of life, you're growing things, but in fact, you can decrease the quality of life in aquatic habitat, right? They also defined a perverse result, or a backfire, as I'd rather call it, which is contrary to what you're trying to do. When you irrigate or over-irrigate, you can actually decrease your yield, and that's something that CSU's been studying, and we have examples of that. So some drawbacks I'm going to go through quickly. I mean, these are pretty obvious, but really it's about quality and timing. When you're inefficient, you lose water to non-beneficial use, it seeps, you lose it to deep percolation, you dissolve, you oxidize, you mobilize natural contaminants, and you can deplete the aquatic habitat. And again, these are pretty obvious, but uneven irrigation leads to poor production. And you can see that throughout these areas. And the other unexpected drawback is salinity. You can either cause saline soils to develop, or that saline materials can flow to the river. Now, obviously, when you become more efficient, you can increase your ag production. You can reduce that contaminant loading. You can kind of restore the natural timing and availability of the hydrograph that a lot of us are trying to work towards balancing. And some of the backfires, you can create inadvertently wetlands from inefficient practices. Just like the Salton Sea we heard about, that's both good news and bad news. You can change the timing of the return flows from groundwater and tailwater. The late season return flows, however, we're going to hear are a benefit. They cool the river, they keep the river fresh in the late season in certain cases. So as you move on, other sort of backfires or unexpected perverse results, you can actually, through increased efficiency, which you want to do, increase your agricultural production, but that can mean more consumptive use. And that's something that sometimes slips by folks, and it has sort of the opposite effect. You can also reduce your aquifer recharge. Again, change the timing and availability of those flows for late season uses. And again, the tailwater and groundwater can be impacted. So as we move quickly, this is just sort of a depiction of a natural system in the red, which you have high spring flows and lower late season flows. That's a natural hydrology or hydrography that we experience here in western Colorado. As we improve, we add reservoirs and we divert and we grow crops, we flatten that out. And in fact, in late season, we have higher return flows than what would naturally be produced. So that's a key depiction that I want you to keep in your mind as others talk about it. Now, as we, I should have a slide here of what's not showing. We pull back and we look at the big basin, right? We heard about that from Eric. We're at a point where we are talking about having to do more with less. The Lower Gunnison project, folks have heard about this. I've talked about it in past years, where we're trying to modernize our infrastructure and really increase our efficiency without these unexpected or these backfires, these undesirable backfires. But we have a big pot of money, and I want folks to understand that we are doing things with the reservoirs, with the conveyance, and at the point of use or the application. So we're trying to hit all components of the efficiency to the maximum benefit and for the minimum amount of detriment, by also requiring mitigation for wetland loss, for other unexpected unintended consequences. We are looking carefully and planning through this process to meet our overarching project objective. And I'm probably running out of time, but the water use efficiency objective is really to reduce that depercolation and seepage that I've talked about. That reduces the salt and selenium that is loading to the rivers that are degrading the habitat and also degrading the ability to use that water. In the Grand Valley, there are issues with salt that's been loaded from the upper basin, and we're trying to minimize that coming down here so that agriculture is not adversely affected by that salinity loading. And the selenium loading, of course, is an issue for endangered fish. So by better managing these, we're hoping to really make an impact while not having any of those adverse impacts or backfires. So that's kind of the setup for two experiences I think you're going to hear about. Don Schwintz is going to go first, and he's going to talk about his experiences in the Dolores Water Conservancy area outside of Cortez. And again, he can probably talk a lot more about this. But one thing I did want to mention that, you know, this is a situation where one irrigation boot does not fit all. Not one size fits all, you know. So we're going to hear some different views, and I welcome Don to the stage.
Good morning. I'm a farmer. That's what I do. That's mostly what I know. The reason I'm here is I've had the opportunity to change from a surface irrigation system completely to fully ag efficient, water efficient delivery in terms of pipeline and pressured pipelines coming in to do sprinklers on my farm. I've always been compelled to track numbers in spite of just being a farmer. Water numbers, dollar numbers are vital to make it in my business. I've tracked the water numbers the numbers I'm going to share with you today are tracking my water use, which I did field by field, year by year, all my years being in this business. Yields associated with that water use, that of course transfers straight to dollars. There have been unanticipated consequences to ag efficiency water use that have taught me some significant lessons. That's part of the message that I'm going to give to you. I'll summarize some of those lessons to start out before I move into the numbers. I still think there's a significant disconnect between Mother Nature's plan for utilizing water and the law and policies that we use to manage and control water usage. We all learned about the water balance equation back probably in junior high school, and we've gotten quite sophisticated about describing the needs and rights of both ag water and municipal and industrial use of water. But I don't think we've brought that same level of understanding to the environmental uses of water, nor to the interconnection and timing of water moving in and out of groundwater storage. And I think that those are both real vital components of that, of really understanding the water balance equation as we move forward developing policy. Just to give you a little more idea, on the slides I've got, I'll just have two maps. This is a broad map of the area. You see the four corners down there, and the yellow parts of the map are the Dolores Water Conservancy District areas. Inside those yellow areas are the green is the old Montezuma Valley Irrigation Company system. That's where I farm, is part of that old one. It's been there since the 1880s. Source of our water supply is the Dolores River. San Juan Mountains are on to the northeast of Cortez. The general terrain flow is from northeast to southwest, heading towards the Four Corners and the San Juan River. The Dolores, you can see coming out of the mountains following that same terrain, and then it cuts to the northwest along an old fault line and continues north and actually finally joins the Colorado River in Utah upstream from Moab. As it does that, it cuts off all the mountain flow, the perennial stream that we would have in our country, and sends it north until the predecessors to Montezuma Valley Irrigation Company came into place. They put a tunnel through that little ridge there, and were able to dig a ditch through a dike. I mean, where we've replaced that with a dike later, but the Great Cut area, they put a ditch through there, and that was the beginnings of service to bringing Dolores River water to a previously totally dry valley. The town of Cortez was literally a company town built because of the new ability to have water there. We wouldn't have had a community. We wouldn't be Montezuma County if those early guys hadn't done that. We would have still be probably part of La Plata County. After that early split, we became a separate place. So the MVI system has been doing its thing for 100+ years. That's where I know my experience. The project water is north and west in the blank spot of the yellow, and its water's delivered out there already fully efficient. Completely different environments in the two areas. The other part of the Dolores project is south and west of me. The purple parts there, that's the Ute Mountain Ute part of the component of the project, which is a major reason we got that project built. But between those two areas, our irrigated acreage in our community doubled, and it's a critical thing for for people from outside to know that we're all trans-mountain users, given the way the law works, as we pull that Dolores River over to the San Juan River Basin. Salinity Control Act had passed as the Dolores project was getting ready to get built, and the importance of doing that, there was planning being done in both efforts at the same time, and salinity control became a feature of the Dolores project, so that my old ditch system that I was farming in, as that unfolded, yeah, there's a yellow line you can see there crossing across the green stuff. That's the Toyac Highline Combined Canal. That's the efficient delivery component of the Dolores project that combined. On the next map, you'll see the two ditches that served the lower valley where I farm, but at any rate, it replaced those two ditches and also then was designed to carry the Ute Mountain Ute component of their project water supply in one lined canal with pipe drops bringing pressurized water to a significant part of the old MVIC system. We can switch to that second map. That's the very tail end of that MVIC system. The yellow lines are literally the south of the bottom yellow line. Is the reservation, and so it's Ute Mountain Ute tribe stuff. There's a significant arroyo on that south side that cuts that off into a very isolated, compact piece. right here is another significant arroyo that was MBI's spill, and it is deep enough that there's no water table that joins the parcels that are south of that with anything to the north. That's one of my farms. That's one of my farms. There's 4 farms in that isolated area. So really I control over half of what's happened there, and my 2 neighbors control the other half. And it's a complicated story, but even where we are, and I didn't know that until we got where we are today. That's going to be the story I share with you. This is a really good place to see an isolated area that really does give you some data to extrapolate to the much more complicated part up above, because the blue line there is the old Rocky Ford ditch that came. It's no longer there, and instead we're served by that buried pipe. I've got 100 psi plus pressure available to me at all of my old head gates that I can irrigate from. So I guess one other quick little tidbit, my farming career started, and as this story began to unfold, I had another farm halfway from this lower end of the MVIC system towards the town of Cortez. In the more complicated areas, it was one of 4 farms that the Bureau of Reclamation used to do a case study on to extrapolate from to find out whether salinity control was feasible in our area. So here I'm a kid. That was the first farm I bought, and I've got the Bureau staff over here, the lead guy, doing his groundwater monitoring. He measured every drop of water I brought on my place, every drop of water I ran off my place. He had wells that he put in to monitor groundwater and see what was going on with there, do water quality testing and that kind of thing. And so what a gift to me that is I like to learn things, and I spent many a lunch hour eating our lunch together on the back of a pickup with him, sharing what he was knowing and giving me a pretty strong kind of more technical understanding of water table and how it impacts your farm. And of course, us farmer guys, we don't live without savvying that. I mean, we just can't make a living if we don't farm around that high water table. But combining the two was a gift to me. So I'll try then and share some of the results of that data that I generated. So I'll give in effect a before. What I was dealing with before I had efficiency improvements, salinity improvements available to me, and then what I had after. And so when I started farming those 2 farms, 20% of the cropland had a high enough water table that you didn't need to apply any water or very little in order to be still raising an irrigated crop. There was another 20% of the cropland that I had available to me that had a high enough water table. You had to be extremely careful with your water management in order to raise a good crop. And for me, I'm a hay farmer. Alfalfa hay was what I started with. So when I say good crop, good alfalfa hay, deep rooted, that was drain enough. So 40% of my cropland was marginal for top hayland, alfalfa land, when I started. And as things began to change, I realized what that water table meant for how much I was relying on it, as well as applying water on the top. There were also significant environmental benefits associated with that water delivery system, and by that, particularly I'll point to cottonwood trees. They're the real obvious thing that we see all over the MVIC system, but more than the cottonwood trees, shrubs and other brush, things that weren't part of your really good crop area, but still the environmental benefits associated with that, including large and small wildlife, were significant parts of the pleasure that you get out of doing your daily chores. Those were, I liked these lower valley farms because of the shape of the fields. I used ditches for everything, marks out of the ditches. I had pickup ditches for picking up we call it wastewater, and reusing that as we went down, sometimes 4 times before the field was finished irrigating. And with some of that capability, I was applying 3 acre-foot per acre, and where I didn't have really good reuse, up to 78 acre-foot per acre for an annual need on for crop water. 1 water application per cutting was enough to raise a really good crop. We had three cuttings, so that's the way we looked at it. A short year, 2 applications of water, you still got almost the same yield because your third cutting had carryover groundwater storage to provide a crop. After I had some infrastructure available to me and I first switched to sprinklers, I could still manage 3 irrigations, 1 per cutting, and raise a really good crop. Boy, I was doing great. 2.6 acre-foot per acre application need. But it didn't take too long before those application rates needed to increase for the yields to maintain where they were. I'd also left gated pipe and pickup ditches initially because I had a more efficient use with some of that water. I could put on, with some of that reuse, I was at that 3 acre-foot instead of, and a sprinkler really did need, I'd found on my other farm, 3.3 acre-foot per acre in order to raise a good crop. So if I'm doing pickup gated pipe and pickup ditches and doing it at 3, I left those in. That yields didn't stay the same. Things began, I had to learn how to farm again. I was having to change nozzle sizes. I gradually replaced the gated pipe system and put pressurized pipe and sprinklers on those places. And 15 to 20 years for me to finally evolve to totally efficient use, driven by, I had to, in order to keep having the yields. So constant learning effort. Where I am now, after these 15, 20 years plus, I feel that I need a 3.6 acre-foot of water application rate to raise the same kind of crops. Before the ag efficiency improvements, the rule of thumb was that you needed about a share per acre. That 3.6 equates to raise a crop. That 3.6 equates out to about 0.8. Some of my neighbors, acre-foot per acre. Some of my neighbors say they can get by with less, and they're right. Some of my water goes deliberately and specifically to protect some of those environmental benefits that were important to me. I now plan on 5 to 6 irrigations per season. Those are 24-hour sets. You can do more with, if you're doing 12-hour, you still got to get about the same amount of water there. And that's way different than the old two irrigations or 3 irrigations per season. What these numbers add up to, I've had to purchase a number of additional MVIC shares just to irrigate the acres that were all being irrigated before. Some of those, of course, I told you were being irrigated for free with that water table. That number totals out to be probably 15% more shares needed, bought to, and owned by me in order to keep the same acres irrigated. Some of my neighbors probably couldn't afford to do that, so they have managed to have had to adapt to that in a different manner. It's really taught me how significant the water table was for providing crop water consumption. And I think we need to find a better way to measure that. Just back to those 20% numbers that were really high water table, the change there, that high water table stuff that has reduced all the way down to maybe even 1%. There's probably 1% of the crop now that I can't raise alfalfa on. And the 20% additional that were marginal, they're just all, I'd say maybe I've got 4 to 6%, 2 to 4% that's marginal. That includes that 1%. So financially, I'm much more productive just because of the better crop I can raise now on what were the high water table stuff. I can get more money out of it. But when you come to total crop consumptive use, I don't know how much it's really increased. I don't have measurements on that, whether those high water table grasses that I grew then, whether their crop consumptive use is different than my alfalfa. I do know I probably have a little extra crop consumptive use driven by the need for more irrigation simply because of a longer growing season that we have today. So to begin to wind down, the environmental benefits that were associated with the old water delivery system have been reduced, and any that are left have to take a conscious effort to maintain both water and time infrastructure. And I don't think those types of needs are being addressed in discussions about water efficiency. We need to find a way to measure those needs and make sure that those benefits, whether they're lost or saved, are properly accounted for. I'd say the salinity program's definitely been successful in reducing salt loading, but it's done it primarily by reducing the return flow water supply through those Mancos Shale derived soils. So the most important thing that I want to share is really this is a complicated story, maybe more complicated than we give it credit for. The lack of adequate analysis numbers to the appropriate, we need to have those better analysis numbers as we have the appropriate debate as we move forward. So I'd particularly like to emphasize the need, going back to that environment. Water is life. Those are simple words. We always know that, but they're not. The understanding of water as life is really complicated. And when water being life, Mother Nature is always grabbing a hold of it anywhere that she can, and she puts it to use the way she wants to. And I consider anything that's not my crop consumptive use, it's her environmental benefit. We need to learn to evaluate those uses and debate whether the benefits are something that our society wants to save or whether they want to sacrifice them. The aquifer storage is another water balance number that we don't have a good enough handle on. The time lag associated with water moving in and out of the aquifer needs greater understanding. There may be significant drought protection provided by that aquifer storage. I know there was for me in the before picture that's not there in today's picture. And so with that, I'll look forward to any of your questions when we get time for the questions. Appreciate the chance to talk to you and share what I know today.
Well, thanks so much, Don, for that, your experience with agricultural efficiency. And now for another, something completely different, maybe. We're going to move to the upper Gunnison Basin, and our longtime board member and water expert, Bill Trampy, be honored to welcome him to the stage.
Thank you, Dave. Good morning. It's really refreshing to see a large crowd of enthusiastic people wanting to listen to somebody like Trampy. I hope I can fulfill your expectations. I'm going to try very hard not to be repetitive to what you've already heard from these two speakers, and so I might be a little disconnected as I move forward, but I do have some things I want to share with you from some personal experiences that we've had there in the Gunnison Basin. I don't know how many of you are all that aware of the Gunnison Basin, but these photos kind of help set the stage of where I'm going to be talking about. This is out north of Gunnison, about 6 miles off of Highway 135 on your way to Cresta Butte. We're looking north on the upper left-hand side. We're looking north from the highway, basically about 5 miles north of Gunnison. You see lots of flat, mesa-type country with the Sagebrush Mountain in the background. If you can visualize that country 120, 30 years ago, it was all rocks and sagebrush, just like that mountainside back there. And so the old-timers went in there and they started mowing off sagebrush and picking rocks and developing irrigation diversion. Early diversions were very small. They thought they were going to be farmers, and they were going to grow grain and potatoes and alfalfa, crops that didn't necessarily need lots of water, but they found out fairly quickly that that water, even though it was small amounts, it didn't go anywhere. All that country is underlaid by gravel, cobble, with from 6 to 12 inches of soil on top of it. And so they learned pretty quickly that they needed to have larger amounts of water to get it to go someplace. And over time, they found out if they could fill that aquifer under there with vast amounts of water, then they could accomplish something by getting water to go over the surface. And I think that our particular ranch really offers an opportunity maybe to really show this. I think most all high mountain valleys are similar. But because we're on the edge of this bluff and this mesa, I think it gives the opportunity to really see what happens. The lower left-hand photo is a photo of the river bottom, and that's from 50 to 100 feet below the two upper level pictures. It's hard to believe, but the river bottom is totally irrigated by aquifer return flows. There's no diversion from the river that's irrigating that. There's about a 50-foot drop between the upper level and the lower level, and all the water that comes out of that mesa is aquifer recharge, and that's irrigating our river bottom country, and for vast areas of the river bottom, not just Trampies, but from 3 miles north of Gunnison to 7 miles north of Gunnison, that total river bottom on the north side of the river is irrigated by return flows that are coming out of the ground. All the surface return flows are flowing to the west toward Ohio Creek, which is the upper, if you use the upper right-hand picture, that's taken in the same location as the left-hand picture, but it's facing west toward toward Ohio Creek. And all those return flows, surface return flows, go to Ohio Creek. And lots of the people on the lower Ohio Creek depend upon that water, that return flow from the Gunnison River to irrigate the lower Ohio Creek. So we've got return flows going two different directions, doing two different things. One of them surface return flows and the other's aquifer return flows. My particular family's had a ditch that ran to a resort, and actually the ditch was there long before the resort was there. But because of modernization of everything, the resort and the ditch and enlarging the ditch over time, the seepage problems out of that ditch into that resort area became a big issue, a legal issue. I went to court 2 or 3 times over the issue that leakage was causing damage to the resort buildings. We never actually lost anything in the process except just the hassle of having to protect your rights. But it just got to the point where, to get along with the neighbors, I continued to reduce my diversion rate, and it just became too much. So I think it was 5 years ago we decided to put that 100 CFS ditch in a 6-foot tube for almost a quarter of a mile through that resort area. And it was quite an experience. It was a $250,000 job, and that's not the point that I'm trying to make. The point was we wanted to do that while we were haying, and so we shut the ditch off totally 25th of July, which is not our common practice. We normally shut the ditch down about half and continue to irrigate pastures, and as soon as we get the hay off a certain ground that we can put water back on, we do that. And so this particular year we shut totally off. And because of engineering difficulties, getting the contractor on board and all the things that go with a project like that, We didn't get started with the project until mid-October, so that whole last part of the summer and the total fall, there was no water diverted out onto this mesa. And so I'm going to try to give you the comparison of the normal and what happened with the dry up. This area in the river bottom that I described on the lower left, by the 20th of September, on a normal year, let me put it this way, on a normal year, you can't ride a horse in a lot of that area. It's too wet. Now what I'm looking at there is kind of the country that we divert the flow out and irrigate, and it could be a hay meadow if you wanted to use it as such. We use it as a pasture. But to the right-hand side of that picture, there's a really low area where that water's coming out of the ground, and we collect it and divert it off onto the higher level that's actually closer to the river. But that area that was wet, or is normally wet, we couldn't ride a horse on it on a normal year. This particular year, by the 20th of September, you could ride a horse anywhere you wanted to. And the area that you're looking at here in the photo had turned brown because it was dry, burning up. That, I always felt that there was something like that, but having never experienced it, it really brought things home to me. That riparian area was devastated for that particular fall. So that told me that that irrigation return flow expands the normal river riparian area to a great extent. And so I just put it out there. It's kind of up to society to help agriculture decide what is and is not important. We found out that that aquifer recharge is really important in the domestic house, because the next spring when we were calving and it was nice to go home to a shower every night, my well was dry for 2 weeks until the snow went off enough and the ice went out of the ditch that we could get water in the ditch and help recharge the aquifer and get the wells coming back. A side light to that whole scenario is, as lands go out of agriculture, which is happening in my neighborhood, and people come in and build houses and drill wells, all of a sudden our normal spring flow or springtime aquifer levels, all our old dug wells and things were 60 to 65 feet deep at the most. And today you better have a well that's at least 75 foot deep. And that's just because there's not as much land being irrigated, in my mind anyway, and so you don't get as much aquifer recharge, and at the same time you're pulling more water out of the ground all year long to satisfy the new homes and all the new development that's around. That's also important to me when I'm trying to fill that aquifer in the spring to be able to get the water to flow over the surface. If you have a bunch of domestic wells and people irrigating their lawns and things before you get going, or at the same time you're trying to fill that aquifer, it just delays your ability to be able to irrigate really efficiently until you get that aquifer full. And so they're pulling water out and you're trying to put it in to build that water table, and it just makes it very difficult for the rancher. Another thing that is kind of interesting is we've heard Don talk about the wildlife habitat that we create with these ditches. It's interesting in my particular case, you've probably all heard about the Gunnison sage grouse and it being a threatened species. As we were thinking, knowing that the bird eventually was probably going to be listed, the Colorado Department of Parks and Wildlife negotiated a candidate conservation agreement with Fish and Wildlife Service, U.S. Fish and Wildlife Service, and we as private individuals could have a certificate of inclusion into that candidate conservation agreement. And of course, I think most ranchers joined the effort and got a CI. And one of the conditions of the CI is to maintain the existing habitat for the bird. And in all of our private land, if you're in the habitat, the critical habitat designated area, all this ground is designated as habitat. And they're particularly concerned about the interface between the dry sagebrush country and the wet meadows, that's great brood rearing habitat. And so if we're going to have to, it's an interesting conundrum. Are we going to have to, as society moves us forward into efficiencies, and we go from open ditches into gated pipe or diversions and sprinkling and all that kind of thing, and destroy that wildlife habitat, we're going to be in violation of our certificate of inclusion with the CCA. So it's going to be very interesting to see how this all plays out in the future. A year ago this past summer, the Foundation for Water Education came to the ranch, and they had asked for us to kind of give them a tour of what we were doing, and we were standing, and the bus had parked along the highway close to the right-hand bottom picture, and we were standing there talking about stuff, and I had just mentioned that I thought that a lot of this ditch bank area between the sagebrush and the meadows was great wildlife habitat, and I had just finished explaining about the sage grouse issue, and Chris Treese thought I had it all put up as an example, and it turned out to be an example. I had nothing to do with it, but we were standing there talking, and I had my back to the area that we're looking at in that photo, and everybody kind of got a funny grin on their face, and I turned around, and there'd been a big old buck walk out of the brush and was standing there looking at us and enjoying his habitat. So all of this leads me to think that we need more information, and we need to be able to quantify and do a better job of explaining agriculturally what we do and don't want. And society is going to have to help us make those decisions, or probably society is going to make them for us. But does society know what they want? I mean, we talk about, and I'm told that we're diverting way too much water, and we're taking way too much water out of the stream, and all those kinds of things. And we come back with our normal thing, well, our return flows are going back to the river, and they're doing this and that and the other thing that I've just explained. But there are certain groups around that still say we've got to leave the water in the river and allow the natural hydrograph to exist. Do we understand what the natural hydrograph is versus what we're producing today? And is that really what we want? I don't know. You're going to have to tell me, because I'm going to do whatever the market dictates that I do. And if I can sprinkle and I can produce more crop and do a better job financially, that's probably where I'm going to go. Because I don't get paid for producing wildlife habitat. I don't get paid for producing aquifer level for domestic wells. And so those are the things that, are those things important to society? If they are, then help us keep it that way. Otherwise, we're going to move where the market takes us. And if hay, grass hay and pasture is valuable enough to me and to society as a whole to afford me the opportunity to go to sprinklers or some other method of efficiency, I'm probably going to go there. But as long as the market says that I can't pay $40,000 for a sprinkler and pay $10,000 a year to run the thing, because hay's only worth 75 bucks a ton, then I'm going to stay where I'm at. That may not please the people that want me to be more efficient, but that's the most efficient I can be for what I'm getting paid. And we need to think about things in that fashion. In society, you guys in the other side of the world are going to have to help us make those decisions by your preferences. And that's all I can say. It's just that simple to me. I think I'll leave it right there, and we'll go for some questions.
As always, an intriguing and thought-provoking topic and thought-provoking panelists. So as you can tell, it's a pretty complex issue. Depends on where you're going, and just want to reiterate that one size irrigation boot doesn't fit all, and welcome some questions.
Dave, as conveyance systems are gaining efficiency, with all the work you're doing, what are the tools that you're beginning to develop and use now for monitoring the return flows?
So I guess I'll take this. It sounded like Art, you were pointing at me, but so in the Lower Gunnison project, which is really a series of projects where we're looking at piping ditches, putting in sprinklers, pressurizing systems the best we can with environmental mitigation. We have a pretty good network, thanks to the USGS, who's in the room, of monitors throughout the basin. And the Lower Gunnison is probably one of the more monitored basins with real-time continuous monitors in the main rivers. And we have seen trends, and we've seen dramatic trends over, say, the last 30 years, especially with respect to salinity and selenium. Those are the contaminants and concerns that we've been looking at, and we have a documented trend of a reduction of between 30 and 40% of those contaminants when you look at gauges in Grand Junction and at the state line. Now, having said that, what we don't have a lot of, and what these gentlemen have talked about, is the on-farm monitoring. It's very expensive to put in the wells necessary to monitor the groundwater in these site-specific conditions, but again, in Lower Gunnison, where my experience is, we do have a 30-well network. We are monitoring groundwater throughout that 30-well network, but of course, 30 wells over 80,000 acres of irrigated ground doesn't cover a lot of that diversity. So I think we're doing a reasonable job, but we've got a lot more work to do, and that's where a lot of the expense comes in, and where the market is not dictating that these gentlemen put in these monitors that are expensive, but a lot of anecdotal data, especially what Mr. Champion was talking about, can also be used and very valuable on how these changes are causing both the intended and unintended consequences. So if you do want more information on the monitoring, the USGS has excellent websites with that data. They published a lot of these trend reports. But again, we have a lot more work to do, and I don't know if you all want to address that.
Part of a CSU study is going to start collecting data on our particular place. We've got, I think it's 12 wells in place now that they've got instrumentation in, that we're beginning to monitor water table levels in conjunction with what we're putting on with automated gates. And we're just getting started in the process, and really what we're hoping to be able to do, and I'm a little skeptical, but I'm willing to go with it, is find out, can we change the application timing and maintain water table enough that we can continue to do what we're doing now. And my concern is we're going to continue to monitor that water table, but I'm concerned that by speeding up, and that's the intent, to speed up our turnout rate, that we won't have enough time for the return flows to do what they do today. In other words, if we speed up by 12 hours our application rates on the head parts of our meadows, today we count on that water, the return flows of that water, the surface return flows, being able to gather it up and use it again and again and again. And if we speed that rate up too much, we won't give ourselves enough time to have the return flows gather up tight enough to accomplish what they're doing now. So that's going to be the challenge. But we're going to be developing a database to know what's happening to the groundwater.
This answer isn't directly to your question, but just to build a little bit on what I was trying to say, that as I've watched this, salt loading numbers are how you prioritize salinity cost share dollars into our community. And those salt loading numbers, I've actually got quite a bit of faith that they're accurate. But as we've watched things unfold, we've also had similar studies to try and calculate water efficiency savings through these same efforts. I frankly don't have faith in that science at all as I looked at my personal experience. It's interesting to really hear Bill's story. It's similar to mine, but in completely different soils. And so he has less than a year lag time to see an immediate result. What really does bother me about the story in my basin, and this has to be true in the Uncompahgre in many places as well, is literally 15 years or more before you finally see the final consequence to the change in water table. And that makes planning very, very difficult. And also, that water balance equation number, water in and out of an aquifer, I've watched it and looked at it with my numbers. I had a chance to spend a ton of money trying down on my place to get some groundwater monitoring to try to isolate some of that water balance equation on 35 acres down there. And I didn't get a satisfactory answer at all out of that, the money I spent there for trying to find that. But that's a really necessary component as we move forward in my mind.
Sounds like we've got time for another quick question. About 2 minutes left in this session, so have at it. Looks like, yeah, either you pissed them off or you answered all the questions. Oh, here we go.
Don, with the reduction in water table and therefore groundwater being evapotranspired, but also a similar reduction in over-application and therefore leaching down, have you noticed any change, or do you have any information on variation over that transition of soil salinity concentration?
I guess in my country, what we've really have learned is that any of the mountain water that we bring down and put on the land is reducing the salinity. Just that place that was further up country that I talked about where they did their study area, literally the Rocky Ford crossed the top end of that, and we found there that there was some deep water under artesian kind of pressure below the Bureau of Science guys. They found that between below a real hard pan that I don't know what, they didn't know where what the source of that deep water was, because there's a lot of farm ground above it in those Manka shale soils, so it may have come from that, may have come off the Mesa Verde. That was a lot longer time to get the water there, but it had really, really high salts as it pushed its way through to come up. And so his words to me was he didn't know what would happen 20 years on that farm afterwards when they got rid of the Rocky Ford with its flushing action to grab any of that really salt water and kick it straight down McCamel in the surface runoff piece. So those pieces together, and I guess you asked about the over-application. I don't know whether it's sickly over-application. I think that what really built the water table are gravel pockets or gravel pieces of the land that grab water out of your ditch or where you irrigate over there and then track it down until you run out of the gravel stuff into the really tight Mancus shales, and then it gathers up and becomes your high water table that's bringing salts with it. But the salts are coming from those soils, and then the introduction of the new water over there is a cleaner water And it's just a pretty complicated set of stuff that's going on in terms of following the water. No. Oh, I guess that'd be my simple answer.
Okay, well, on that simple answer to a complex issue, we're going to yield the floor and bring up another panel. So before we do, please thank our panelists.